Okay, so it's 3 p.m. So we can start. Okay, Anirudh?
Yes, Siddesh, I'm
Yeah.
here.
So the aim of our event is to help professionals explore upskilling opportunities in core engineering and automation industries, and to share their knowledge on trends and opportunities in emerging sector, to extend hiring opportunities as well, and to educate and train our participants in cutting edge tools and technologies that are going to be part of Industry 4.0. So, as our event highlights are, we have got speakers from international institutes like EIT Australia, LinkedIn, Udemy. We have got participation by Metro, IDC, EIT Australia, and ThinkPrint, as we are going to have in this event. Our industrial topics have been ranging from e-mobility to autonomous vehicles, smart city, digital manufacturing, Industry 4.0, instrumentation, 3D printing, and much more. So we also had a special session for women entrepreneurs for starting home manufacturing ventures, digital transformation, growth for women entrepreneurs. So it was been held by Shweta Thapa. She is an Udemy expert. So on 3D printing, we have had this entrepreneurial workshops by 3D Stars as well as Shweta Thapa. And now we are going to have a talk from 3D Think Print on 3D printing and its applications. We had a mega workshop from a German-based company that is Metro, is one of the leading manufacturers in chemical analysis instrumentations. As part of our event, we also had some job opportunities from 50 plus companies and 200 plus open positions. And even ThinkPrint is hiring some of our candidates in industrial designing domain. So we also had some 6 plus workshops regarding instrumentation, process, panel designing, data analytics. And we'll be having one more our workshop by 4 p.m. starting by 4 p.m. At the end of this event, the viewers, the attendees will be getting some courses worth rupees 50,000 from Udemy as well as IDC Australia. So please tune in and then you can get all these benefits. So coming to the LabDocs. So what is LabDocs? So LabDocs is a platform that helps learners to acquire engineering and entrepreneur skills from core engineering, scientific science field. So LabDocs offers programs and modules in emerging technologies like 3D printing, drone technology, robotics, data analytics, and AI and ML. So LabDocs has always helped learners acquire core engineering and entrepreneurial skills because that is things that are of utmost important in today's world. So why we do and what we do? So we want science and engineering professionals to acquire skills that are practical, that are employable and applicable. So there are so here we are bridging the gap between what you are taught in schools and colleges and what is required in the industry. So the skills are mapped to the industry requirements. So our focus area, as we have said, that it's digital manufacturing. So 3D printing comes under it, industrial IoT, robotics, instrumentation and control, drone technology, agriculture technology, clean technology, and product innovation. So today, Anirudh Ravi has joined us. So he's a Bachelor of Economics from University of California, San Diego. So he's US-based business growth manager, and as a business growth strategist, he has helped SMBs and institute stay connected with their stakeholders. He has worked with companies like Kevin Care, Cloud9 Solutions, OmniLab, and many more. I think OmniLab is also his venture. So currently, he's the head of business development at ThinkPrint, which provides 3D printing prototypes to businesses. And he has founded it with his school friends, that is Anubhav Goyal as well as Kanishk Lora. So as part of our event, so today we had a workshop on 3D printing for women by Shweta Thapa, Future of Smart Cities by Jonathan Rosenthal. We had a beautiful session by Feras Nasser, who is an Udemy instructor on e-mobility and the opportunities that are present. So right now we are having this 3D printing in industry. So yeah, guys, this is a poll question coming towards you. So just state what is your profession, uh, and then Anirudh can give a good answer to your queries and all that stuff. So at 4 p.m. we are going to have our final workshop on instrumentation, panel designing, detail engineering by Arfaq Ahmed. So he's also an Udemy instructor, and you can get a lot of benefit from that. So this will be all from my side. I would like Anirudh to take over from here. Okay, Anirudh?
Sure. Thank you so much, Siddesh, for that fabulous introduction. Can I share my screen with everybody
Yes,
now?
yes. Go ahead.
Okay, I'm just ending the poll. Looks like most of you are students. I got my answer. Thank you. Great. Hope you all can see my screen. Okay.
Yes, it's visible.
Great. So, hey everybody, my name is Anirudh Ravi, and like Siddesh said, I'm the head of business development at ThinkPrint. Just one correction there, Omni Labs is not my venture. I do work for Omni Labs on the business side, however. So telling you a little bit about ThinkPrint before I get into today's talk. ThinkPrint is a 3D printing company that aims to provide accessible, affordable, and on-demand 3D printing services to small manufacturers and big manufacturers alike. Throughout this talk, we'll be highlighting some of the trends in the industry of manufacturing and just that entire environment and what technologies are being used and what Industry 4.0 is and how you can make or how you can acquire the certain skills that help make manufacturers ready for Industry 4.0. Okay. So I know 3D printing is not a new topic for many of you guys by now. It's a very famous technology. Everybody's heard about it in some form or the other. However, this technology is maturing very fast and expanding rapidly into multiple applications across different manufacturing facilities. So today's agenda would be to discuss the trends and methods that companies are following and using to integrate additive manufacturing into their factories to make them future-proof and ready for the future. So we will be discussing briefly what Industry 4.0 is. We will discuss the different technologies required to achieve goals set by this Industry 4.0 framework. Then we'll dive into why additive manufacturing is important for Industry 4.0 and some of the commonly used 3D printing technologies and methods. And then we will see some case studies from some leading companies that use additive manufacturing at different levels, right? So they all necessarily don't use it in the same way, but then they use it to make their process more efficient. So moving on to the next slide. Great. What you can see here is basically a picture of all of the industrial revolutions that have happened so far. Right. So when we talk about Industry 4.0, we are basically referring to the fourth industrial revolution. And this consists of automation and digitization of industry and all business related processes. Right. So the goal is to create a smart factory, right, with robotics, AI, data-driven solutions, and 3D printing to make it more efficient and just get it ready to be more flexible and bring in all of those newly required engines that run a factory. So Industry 4.0 groups physical systems like robots, sensors, digital systems like cloud and the AI, and human beings or the human capital, which runs a company, including the CEO to the worker, all of them into a network where that helps the manufacturing process become more intelligent and efficient. So as you can see, we've lived through three industrial revolutions, and we are in the fourth one right now. What does Industry 4.0 and what technologies does it include, right? So some of the technologies, as you can see on the image on this slide, is big data analysis, additive manufacturing, robotics, industrial Internet of Things. And it is a combination of all these technologies that give birth to Industry 4.0, right? So some of the goals that have been listed out in this framework, and some of the goals that most companies are trying to achieve with their manufacturing facilities is as listed here. So decentralized manufacturing, basically having the distance between the end user and the manufacturing plant cut down. Imagine having 5 smaller plants instead of having one huge plant, which helps you cut down on travel costs and time and everything like that. Heightened flexibility, obviously, it's very important in today's world to react to what's happening in the world. We've just had a scenario with COVID where the entire world was trying to react and make their supply chain more robust. So heightened flexibility is very important. Reduction of waste, both material and time, right? Industry 4.0, one of the pillars of Industry 4.0 is basically to become more conscious about the environment and to make manufacturing more sustainable. And one important goal there is to reduce material waste and time. Industrial Internet of Things basically refers to the concept where you use different systems like robotic arms used in Tesla factories, sensors, and all of the other technology that is involved in your manufacturing process, basically creating an environment where they can communicate with each other through the data that they're collecting, and through computer code and human instruction can learn from each other and become more efficient. And that brings me to big data collection and AI-driven design. This refers to the phenomenon where the world is collecting more data than ever before, right? So many companies like Amazon and Google are making money just by selling data storage space. So you know how much data we're collecting, but the important thing is that companies are focusing on using those numbers to make their manufacturing processes and every other process involved in a business more efficient, and also build on artificial intelligence. So all of you students looking at career choices, please look at these points and see how you can acquire skills that adds to any of these points. Coming to my last point, predictive maintenance and adaptation basically refers to a situation where a machine can kind of predict when it's going to shut down or break down and give you an alert, or give the manufacturing manager an alert that something's about to happen. And they can, instead of reacting to a situation that's already gone wrong, can prepare for a situation that's about to go wrong or even prevent it. So summarizing Industry 4.0 in 3 words: making manufacturing flexible, intelligent, and autonomous. Moving on to the next, okay, my bad. Okay, now coming to 3D printing itself, why we're here. Basically, 3D printing is a very important part of Industry 4.0. But one thing that needs to be noticed here is 3D printing alone, or robots alone, AI alone cannot solve the issues that modernization of manufacturing poses. But in a combination of all of these technologies coming together, depending on what the manufacturer needs, how big his company is, what his budget is, you need to combine all of these technologies to achieve those goals that we mentioned on the previous slide. However, what can 3D printing offer, right? Among the goals that we discussed, 3D printing can actually solve a lot of those issues, right? Coming to it, 3D printing can reduce material and time waste, obviously, and we'll be diving into some case studies which show you in real world where they reduce material waste and time waste. They enable distributed and reliant supply chains. You could have multiple 3D printing farms, you could have 3D printers in your own manufacturing facility to create tools on demand and have a more robust supply chain, which again will be an example in one of our case studies, allowing production of complex designs. So companies are increasingly becoming reliant on feedback from their customers. And what that is doing is changing the fundamental design process and thought process, and companies are having to become more responsive and reactive to those design changes that customers are demanding. And those designs can be very complex, and 3D printing enables you to print any complex 3D object, which is great. Enhancing flexibility in manufacturing and design, as we covered in the first 2 points. What I'll be covering next, like I said, will be a few commonly used 3D printing technologies, right? FDM, or fused deposition modeling, basically extrudes a melted material and layers it out in the shape that you want. So you basically design a CAD file, a 3D model, push it through, and you get your result. It's great for proof of concept models and simple prototyping. It's also very inexpensive. So it's a great tool for startups that are looking to get into the hardware space. And this is a great tool to prototype your technology. Going into the next one, SLS, or selective laser sintering, basically uses powder as material, and this powder can vary from different materials depending on what your use case is. But what it basically does is binds that powder through laser beams and technologies, and can actually provide very high grade and high quality outcomes. So as some SLS printers actually make end user products. As you can see here, they have a very close metallic finish, and they can make a functioning prototype, so a mechanical tool that actually moves where all the mechanical integrations work can be done through SLS. Going to the next one, we have SLA, or stereolithography. In my opinion, this is the coolest 3D printing to kind of watch in a time lapse, because you see a structure rising from a pool of resin. Again, using lasers, what this technology does is combine the molecules in the resin and come up with the 3D design that you've had. This technology can again be used for functional prototyping, patterns, it can make very complex designs, and tooling and molds. It's also very light and also comparatively very affordable. That brings us, to the first case study, talking about Omni Labs, where I was a part of the team for a very long time, and I still work with them in some capacity. They are basically a robotics company that produces a modular platform. So their entire idea is they have technology reuse of 90%, right? So they can reuse 90% of their technology in all different robots that they are planning to make or about to make. The robot that you can see right here is a Telepresence Robot, which can be operated from anywhere in the world. So if you have one of these robots, it could be sitting in Delhi, you could be in London, and control the robot, move around, talk to people, take a look at your manufacturing facility, make sure that all processes are going well. So basically multifunctional, right? But what they do is they use 3D printing to manufacture all of their robots. They've sold around 5,000 robots over the last 3 years. And even during COVID, were able to double their production because they had 3D printing integrated into their manufacturing process from the beginning. So what that allows is to use the basic internal components of the robot, but to create any external body, right? So if tomorrow a big company like Google comes to us, or Volkswagen comes to us and says, hey, we like this robot, but we would like it to look different, we could do that because we have a 3D printing farm, one in Vietnam, one in the US, and just prints out different components of the robot, and most of the technology is reusable. So in this way, Omni Labs has a lot of potential to scale, right? Easier prototyping, and much more reuse. So it cuts down a lot of costs for them, even though they're releasing new products every year. Going to the next case study. Here we're talking about Volvo, which everybody on this call probably knows, but a lesser known section of Volvo is they make construction equipment. Like you can see here, a huge hauler, which is used in mining. So What happened here at Volvo is their management folks, right? So the C-suits like CFO, CEO, they went to the engineering team and they told them, hey, we need a much more efficient way to do our prototyping. You guys are taking too long to produce a prototype and test it out, and we need the product to hit market much quicker. So it was a good point, and I'm talking about around 4 to 5 years ago, right, when 3D printing was kind of still picking up and becoming mainstream. They evaluated 3D printing as an option to prototype. So the two small pictures that you can see on the slide, the yellow translucent ones, is basically a part of a hydraulic pump that goes into the engine of this huge vehicle. So one of the concerns they had is, will this give us the right results for testing? Will it be strong enough to handle the pressure? And no surprises there. They used stereolithography, and it was a functioning prototype. They got the right measurements, and it was a successful prototyping phase. So now it's become mainstream and part of Volvo, where they use 3D printers from companies and 3D printing services to get their prototyping done very quick. And as you can see, the table here mentions the immense difference between using 3D printing for this process and not using it. $10,000 before 3D printing and only $770 after 3D printing, and cuts down, it's literally 10 times faster. Okay. What you need to understand here is Volvo is a huge company, and each of their engines, they prototype at least 12 to 15 times. So when you scale this cost saving and time saving up, it's a huge impact, right? So Volvo is a company that follows Industry 4.0 framework, and this is one of their major plays to become future-proof. Going to the next slide. This is one of the most famous dental labs, right? Recently went public. The company is Align Technologies, and they make this product called Invisalign, which is basically retainers to fix your teeth alignment. And one of their major competitive advantages in the market has been 3D printing, right? So what they basically do is use CAD modeling to get a 3D scan of the patient's mouth and just put it into a CAD file and start 3D printing it, where a doctor digitally stimulates how the dimensions should be. So a doctor is involved, a technician, basically, a doctor is involved in designing the course and plan, but all of their products, the final product that the customer gets, their entire Invisalign braces are 3D printed. And they also use stereolithography. They use some very high-end, complicated materials as well, which does make their product very capable, actually. And they mentioned, I did talk to one of their sales representatives and was just talking to them about what they thought about 3D printing and how it's helped them. What they say is, printed molds can be used to make retainers basically on the same day as you get your braces out, basically giving you a better customer service, right? A lot of doctors actually get roped in. So they tie up with clinics to get their customers. The sales rep also said printed molds are more accurate than the previous method where patients bite into clay and you give it to a lab. It allowed them to make clear aligners, right? How braces look. Not a lot of people are comfortable with that anymore. So they've actually revolutionized the entire market by giving clear aligners and making people less self-conscious and more confident, even with aligners, right? And obviously reduced the overall cost of retainers. Every time somebody had to go to a dentist and get their plans remodeled, get a new retainer, costs a lot of time, a lot of money, but now it's all just done online. You get your 3D printed retainers ready and good to go. That being said, all the benefits of 3D printing need to be applied regardless of the company size. And that's why ThinkPrint is kind of trying to push this effort where we provide services to our clients where they can use our 3D printers, regardless of their size, regardless of how much funding they have or whatever, to use it at any level they wish. Even if you want one prototype, you want to use one 3D printer, great. You want to use 100 3D printers, and have a back-end supply chain set up, you could do that as well. And all of this on demand. So a few things that we're working on right now is consumer electronics, consumer goods packaging, automobile parts. We're also partnering with companies to help them manufacture drones, robots, custom consumer goods, healthcare products, and tooling, basically trying to provide manufacturers custom tools for their machines on demand, right? It's very difficult to find, it has to be shipped all the way from Germany sometimes. But if you have the design and if you have the right design team to make it for you, you can obviously make it on demand within 24 hours or lesser. In the future, ThinkPrint has an expansionary vision. What we're trying to do is have 3D printing farms set up in major manufacturing hubs across India and give our customers the ability of providing themselves with distributed manufacturing capabilities. So say something breaks down in Bombay in a factory and you need a tool, instead of shipping it all the way from another country or Chennai, you could 3D print it right in Bombay and fix it. That being said, right now, I'm open to questions. Anybody who has questions can kind of ask me, and that'll be where we would end this. Wait, do I have to look at the chat for questions? PPT is stuck. Okay. Sadesh, can the participants talk? Hello?
Yeah, you can, if you want, you can unmute them and then they can start.
Okay. Are you the host as well?
Just a second, Anil.
Yeah.
Yes.
Yeah, you're the host too, right? Can you just let me try and unmute the participants?
Okay, just a second.
Okay, I just gave you all permission to unmute yourself. So if you have any questions, regarding any of these slides or any of these technologies, please raise your hand through Zoom and I can call you up. No questions?
So we have some questions in chat box.
Okay.
So how 3D printing affects environment?
Sure. So like any process, 3D printing does consume electricity as of now.
Hello, Akshay.
That's okay. So Jayesh, or no, sorry, Shiv, how 3D printing affects the environment. So 3D printing actually is, when deployed properly and used efficiently, is actually better for the environment, right? Like I mentioned, it does save a lot of material, right? What happens with traditional manufacturing is you either have a mold which molds your metal or substance into the final shape, but then it needs a lot of finishing touches, a lot of interior holes and connections need to be cut out, and that material is not necessarily reusable. However, 3D printing, because of its very nature that it is additive, it only applies and adds material that is necessary, doesn't waste as much material, right? And there are a lot of energy efficient 3D printers, right? So you can think about this technology as, a desktop or, any other ink laserjet printers that you guys have. The older ones were energy inefficient. And as time went by, companies found how to make better products and more energy efficient products. And I honestly believe 3D printing is at a point where they are already energy efficient. It's about choosing the right product for your manufacturing line. Does that answer your question? Okay, I guess so. What are the major challenges that industries facing for 3D printing? Jayesh, can you give me some more context? What do you mean by challenges? Are you in what sense? Can you unmute yourself and talk to me? Jayesh, are you on the call?
Yeah, he's just.
Okay.
So he might be
Jayesh,
asking about some.
how many new opportunities it will create in the next 5 years? By it, you mean our company?
I think it refers to 3D printing.
Or
Yeah.
3D printing. Okay.
Yeah, even Jayesh has told his views.
Challenges in the sense, what are the difficulties industries facing in the current period? Sure. Jayesh, so to answer your questions, right? So 3D printing so far has been done by a lot of companies that, obviously produce their own 3D printers. What is difficult to achieve is to get a 3D printer for your custom needs, right? Sometimes, your design might just be too big and there's no 3D printer to, accommodate that design. Or, one of the other things is not a lot of materials still need to be researched on before they become 3D printing ready, right? Even though a lot of materials keep coming every year, they keep getting approved. There are a lot more that can be researched and done. And I honestly think 3D printing is lacking majorly when it comes to talent, right? So having the right engineers to not only use the 3D printers, but to fix it, to improve on it. Just to give you an example, Omni Labs, as you saw in the video, they manufacture their own 3D printers. So they don't sell 3D printers. They don't have a business of 3D printers, but they manufacture 3D printers for their specific needs. In that way, they can increase the base, increase the extrusion rate, make it custom for their own needs. So I feel finding a custom product is difficult, and to develop your own 3D printer is possible, but can be expensive. Okay. Yeah. So, but remember, the major challenge is talent. So if you're looking to have a steady, well-paying job in technology, especially hardware manufacturing, CAD designing, knowing how to use a 3D printer, knowing which technology is best for your product and design is important, right? And you can find all of that on YouTube, LinkedIn. Follow all of these 3D printing companies, right? They come up with research and white paper telling you what technology is coming up and what they're going to launch next year. So it's good to know what's out there. 3D printing technology reference. Okay. What is the next one? Why applying 3D printing for metal is a challenge? Jayesh, to answer that question, I wouldn't say it's a challenge necessarily. It is just very, very expensive, right? So I forgot to mention during the talk, but then there is this new concept called Additive Manufacturing 2.0, right? A very cliche 4.0, 2.0, but Additive Manufacturing 2.0 basically talks about blender jet printing. What that does is mass manufacturing of metal parts, right? It has very less post-processing and things like that as well. So it is possible. I don't think it's necessarily a challenge, but it's very expensive. How many new opportunities will it create in the next 5 years? Honestly, globally, I think many opportunities, right? So if you're sticking to just one country, it is difficult to, answer the question. But I honestly think India has a very big play when it comes to 3D printing or additive manufacturing, and in general manufacturing, right? So everybody knows the general sentiment now. People don't want products from China. However, the sad reality is they are years ahead of any other country, even the United States, when it comes to manufacturing, right? The technology they use, the talent that they have at that level, and the efficiency with which they work is kind of unparalleled. But through the introduction of technologies like 3D printing and making it mainstream in India, and to have more talented folks pushing these technologies into the manufacturing field, I think it will create I'd say a lot, maybe in the few lakhs, maybe 5, 10. I necessarily cannot put a number to it, but you can think about the scope, right? If, say, people start moving their manufacturing facilities from China to India, right? We're talking about big companies like Foxconn that make iPhones, or even a lot of Indian manufacturers who outsource to China, moving it back to India. It's a great field to be in, manufacturing in general. Challenges in the sense 3D printing technology. I've heard about 3D printing organs, skins, and living tissue. So is this the future? Can this happen in mass production economically? Great question, Shivam. I did want to touch upon that as well when I spoke about Invisalign, but healthcare is a huge sector for additive manufacturing and 3D printing. And like you said, people are 3D printing organs, skin, live tissue, but it is much more difficult than manufacturing, hardware and products. So there is a lot of testing and approval still going on when it comes to medical and healthcare things. The approval process and testing process is very lengthy. So to make it mainstream enough, to make it affordable and to make it a mass production effort will take time. I would say maybe the next 4 to 5 years globally. In India, I do know that there are a few companies that already, 3D print limbs and, arms, bionic arms and things like that. But to make it, economical for the masses, where, everybody who needs it can afford, 5 to 6 years at least from now. Okay. If you don't get the answer to your question, please unmute yourself and let me know, guys. Okay, thank you. Even when 3D printing has been around for quite some time, why has it not yet caught up to the same level as other industrial processes? Wali Azam, great question. And your answer to that is companies can be very difficult and resistant to change. Okay, unfortunately, the corporate structure sometimes is such that, you'd expect a company to kind of realize this and, turn into 3D manufacturing, but they just don't do it because they're skeptical, or, it just takes too long and they've still not gotten to it. And priorities for companies are different, right? If something is going good, let it go good. But let me tell you, as we go into the future, you will see more and more companies adopting this. And to also answer to your question, I honestly think we don't know a lot of companies that are using 3D printing, right? For example, I don't know if you knew that Volvo used 3D printing, or Omni Labs used 3D printing, or Volkswagen uses 3D printing. They necessarily don't talk about it, but trust me, all of these Fortune 500 companies that are in the manufacturing sector use 3D printing in some form or way or another. Like I said, not everybody uses it in the same way, right? Not everybody uses it for mass manufacturing and things like that, but they do use it at some point in their manufacturing process. Which software tools will you recommend for additive manufacturing? So one good method to kind of find that out, Ruchi, is to look at companies, like we pointed out, look at companies that are in manufacturing, do some research if they use 3D printing, right? And then try and connect with some of them on LinkedIn and find out what their design team works with, right? So I do believe that there are a lot of softwares and tools, that you can use to, create, CAD files and to do testing like ANSYS and, a bunch of other CAD softwares. But what really sticks is to know what the company that you're applying to is using and to be well versed in that. So, find out the top 3 on Google and try knowing the basics in at least all of those top 3. Does that sound good? Okay. Shiv Banderi, is there any rules and regulations to control what to print? Very good question. Yes. So basically in the US, I've seen videos on Instagram where people 3D print guns, but, and it is lethal. Trust me, like they work as well as any regular gun, like produces the same amount of force, can be equally harmful. But, that's a question for the government, right? And like with any technology, they will catch up to what people can do with it and will pass laws. I do think 3D printing is mature enough where, the government is already aware of this, and there are probably laws prohibiting people from just owning arms in India. So, to be honest, in your house, you could use your 3D printer to make anything, and I don't think anybody will catch you. And that's the boon and the bane of the technology, right? So it will be hard to kind of control and regulate because, 3D printers have become mainstream and anybody can get their hands on a, fair enough 3D printer if they have, some money. But I do think regulations will follow once this becomes more mainstream. I think so far in India, 3D printing has been reserved, for already established companies that use, top cutting edge manufacturing technology. So far regulation has not been a concern, but once it becomes mainstream, it will come. What will be the 5 best skills to acquire in 3D printing? Like one of them is learning CAD modeling software. Right. So it's not just about, obviously to, perform in any job that involves a certain technology, you need to know the software and hardware component, at least the basics. And, if you've not done a course in college, but you're still interested, in getting into manufacturing and especially additive manufacturing, I would recommend doing LinkedIn online courses. And there are a lot of videos on YouTube, you'd be surprised. But the 3 to 5 best skills I feel is to be, creative enough to think about how to make everyday simple products more efficient and more attractive to a customer, right? So one major component of a 3D printing industry is the designer or the guy who basically, creates the CAD file. So it's not just enough to know the software, but to be imaginative, be creative, work on that aspect of your thought process as well. And the second thing is to do research on, what 3D printing is going to be available in 2 years from now, right? Can you use the same technology that exists today to achieve, a close enough prototype of the future? Or, are you going to have to learn new software? So to do a lot of research and to be updated about the industry, right? To follow leading publishers, to follow companies that produce 3D printers like Stratasys and a few others. But yeah, that's what I would say there. Looks like that was the last question. Anybody else? Nope. Okay. So cool. And also the point of this discussion was, because ThinkPrint is a 3D printing company and provide 3D printing services, we focus more on 3D printing. But any of these technologies in this wheel has a great future, right? So all of these are going to be, coming together. So when you say 3 to 5 best skills, I would say diversify, right? So when you think about manufacturing or 3D printing in this instance, don't just think about the CAD, modeling and software involved in 3D printing, but think about, how does it work on the cloud? Like, can you simulate stuff? Like, how can augmented reality come into 3D printing? Can you design something in an augmented space that you can 3D print, right? Can 3D printers talk to other machines and get, start producing tools even before you ask for it, right? Is that possible? So think about it, from a holistic point of view, where you kind of need to understand all of these components to be a part of, the future of manufacturing, and to also be valued by your company, right? A lot of companies value people who understand the different aspects. So I would say don't narrow in just now because you're all students. Keep your minds open and explore all of these opportunities. But 3D printing is amazingly, future proof. It has a long way to go. So if you decide to go for that, do it without any second thoughts. Thank you, Shubhakant, for the nice comment. Sudesh, are we on time or?
Yeah, we are perfectly on time. Okay. So yes, you have shared really very much valuable knowledge with us. And I would also like to thank participants for being proactive and asking questions. I hope all your questions have been answered by Anirudh, and he has given a nice
we wouldn't mind sharing the slideshow if anyone is interested.
Okay, Anirudh, you can share with us, then we'll forward it to our participants. There are a lot of questions, or there are a lot of messages also that have came up that due to some examinations and all, they have missed this session. So we can definitely share with them.
Sure, sounds good. Thank you, everybody, for participating. Really enjoyed this session. Thank you.
So yes, guys, we can wrap it around here. So we are also having one more session, workshop by Afaq Ahmad. So let me paste a link for that session. So you can all join there and get knowledge about industrial engineering field and the things used in it by top companies.
Thank you, Sudesh. We'll talk later.
Okay, Anirudh. If you want, you can also join in and just check it out.
Yeah, sure. It's 3:20 a.m. for me in California. So I'll probably go to sleep.
No problem. Wait.
Okay. Thank you, everybody. Bye-bye.
Okay, guys, if you want, you can join this session right here. Or else we can end it over here. I'll wait for 2 minutes and then we can stop it. So yes, Shubhakant, you'll get your coupons. Also, you can join this session. So industry speaker is from also teaches on Udemy platform. So he'll also be sharing some courses with you, which you can definitely join in. Okay, guys, then I'm ending it over here. It was nice having you all participate in this event. Thank you. Thank you.